MS Ramaya University of Applied Sciences.
Hi students, let us discuss pulse width modulation. The objective of this lab session is to study pulse width modulation. The theoretical concepts have already been explained during the hardware implementation. Students, let us try to simulate and analyze the same. Sampling is a process of converting an analog signal into a discrete time signal. The simulation of the sampling process is being explained through a simple Matlab code. As an initial step, the workspace, command window, and unnecessary figures are closed. The frequency of the analog signal is entered. The frequency of the carrier sawtooth is entered. The amplitude of the carrier signal is set to 5. A time axis has been initialized. A carrier sawtooth signal is generated for the entered frequency and amplitude using sawtooth command. The carrier signal is plot using plot command. The information signal is generated using sine command. Further, the information signal is plot using plot command. For generation of pulse width modulation, the length of the sawtooth signal is found using length command. Then the amplitude of the information signal is compared with the carrier sawtooth. It is found that if the message signal amplitude is said to be greater than carrier signal, the output is represented by a pulse with amplitude 1 for the given duration. Else, if the amplitude of the carrier is greater than that of the information signal, a pulse of amplitude 0 is generated for the said duration. The results pertaining to the pulse modulation is plot. The results shows the carrier signal followed by the message signal and then the pulse width modulated signal. The experiment can be carried out for varying signal amplitudes and frequencies. The code developed is loaded into Matlab. As an initial step, the workspace, command window, and unnecessary figures are closed. The frequency of the analog signal is entered. The frequency of the carrier sawtooth is entered and the amplitude is set to 5. The Run button on the toolbar can be used to run the program, and the program is run. The results pertaining to the PWM is plotted. The figures depict the carrier signal followed by information signal and PWM output. The experiment can be carried out for varying signal amplitudes and frequencies.
At MSR, you arc your imagination.